Okay. All right. So here we go. So how? That was nice. How to find the? You should write this in your lab books. Yeah. And for this simple case, we'll assume the object's launched. Where the object is launched from and where it lands are the same height. Are you guys, did everyone hear that? So that makes this equation you can call this delta x because the change in position is going to be horizontal for this range equation. Everybody good? That definitely makes life simpler. So you got some random initial velocity at an angle, okay? You've got a being down, 1/2 at squared has to be down, and you got delta x horizontal. Everybody good with that so far? Okay. And this is any angle theta. That's what makes this powerful. So V naught t and 1/2 at squared have to add as vectors to give us our delta x. Good? Cool banana? Yeah.
I've never understood why delta x is in the hypotenuse if those are supposed to add up to equal delta x.
Awesome question. Can you say the question slower and see if anyone has a response?
I've never understood why delta x isn't the hypotenuse.
So you think delta x should be here?
Yeah.
Brilliant question.
Like I know alpha just doesn't make sense to me. Like I know this delta x is changing x, but I feel like it should be the hypotenuse.
Can anyone lend a hand here? Go ahead, Christian.
It might not be a right angle all the time, so theta is always changing, so that means that the triangle is not necessarily the right angle.
Did that work? Or are you just saying,
Yeah.
Don't just say okay.
No,
I didn't quite get what Christian
don't,
was saying.
Don't just automatically think of it as a 90 degree angle.
Okay. Cool. Let's scroll down. Okay, so what's going to come natural right now? Definitely. What direction is the displacement? That's a key element. Good. Okay, so I'm going to ask you again, what would come next naturally? Well, okay, now what do we do here with this?
Tangent.
You could use tangent. What else could you use? Okay. So, Batman, how are you today? So, what's sine theta? Go ahead, Batman.
Sine theta would equal the 1/2 at squared
Okay.
over
1/2 at squared over,
the hypotenuse.
what's that?
V naught t.
Everybody good there? Okay. I'm going to claim we only need sine and cosine here. And I'm going to make this a little simpler. I'm going to argue that sine theta is going to be, let's see, at over 2 v naught. Do you folks see how I got that?
Yes.
Okay. Cool banana.
T squared.
Okay. This is t times t, and there's a t there. So it divides into itself once. You guys good?
Yeah.
Okay. and I can make it prettier, but there's probably no point right now. Well, might as well solve for t. Do you understand why I'm going to solve for t? The vertical motion, the vertical initial velocity, always determines the time that a projectile is in the air. I mean, when you launch a projectile horizontally, you remember that problem? You drop a projectile and you launch one horizontally. What's the difference in the time they take to hit the ground? The reason is because the vertical velocity is identical. Not the horizontal, it's the vertical velocity initially that counts. If you launch a projectile straight up with any old random velocity, and then you launch a projectile at an angle, but the vertical component is the same, guess what? Same time for what? The horizontal range is going to depend on the time and the horizontal velocity. The time is going to depend on the initial vertical velocity. You guys good? So I'm going to solve for time here. I get 2 v0 sine theta is equal to at, and then so therefore, let's see here. Whoops, that was nice. So t is going to equal 2 v0 sine theta all over a. Everybody good there? We're basically halfway done. What do you think the other half is going to involve? Huh? Cosine? Yes? TD? Okay. So cosine theta. Oh my God. Thanks for volunteering, Alon. Tell me what cosine theta will be. I can almost hear you. What? Beautiful. Nice work. And since we want the range, why don't I just solve for delta x? Go ahead, Wexler.
Well, I thought we said not to assume that t is a hypotenuse. So how come we were doing like so good for in order to do the
Okay. In this specific case, is this a right triangle? When we have delta x here.
Well, I thought we said not to.
This is a good question. Go.
If delta x is horizontal, then it has to be a right triangle. If one at x is squared is down, then v0 will be the hypotenuse.
Doesn't that like discredit everything we talked about? The question I asked earlier, why delta x shouldn't be the hypotenuse? When I said delta x should be the hypotenuse, that's no.
Hey, check it out. Yeah. Go ahead.
So if we're using delta x and not delta r, delta x is just going to be horizontal.
Yeah.
So it's only going to be the flat line on the bottom. Meaning its vertical or its horizontal position doesn't change from when it's launched to when it lands on the same level. And then we know that gravity is always going to be straight down. Yeah. Then we know that we're not.
Is this helping?
Okay, so the v0 it is a hypotenuse.
Only in the case of delta x, not delta r. If delta r is good with that, it can be started with that. Yeah, it doesn't necessarily have to be
I think we're speaking too abstract for you, right?
No, I kind of got that.
Let me give you a quick example that's unlike this equation. You guys ready? And I like all the comments. You launch an object. Here. I'll just do it. I just don't have an object. Can I have 1 carrot, please? Carrot, 1 carrot. It just won't hurt it. A harmless carrot. Okay? You launch it, and it hits the wall. Right? Now, you can figure out where on the wall it hits, all kinds of things. Even harder, you could launch a carrot Check this one out. What if you did that? Just think of your displacement.
Yeah.
How do I draw the displacement arrow?
This is 1/8 squared.
No, hold on. I started here. I ended there.
Yeah.
Displacement is an arrow going from where I started to where I ended.
Okay.
This is when you have to use delta R. You're not going to make a right triangle now.
All right.
Because here's your V naught. Your V naught's actually like, the way I drew it, it's like up here somewhere. And then and this arrow is supposed to end exactly there. So I'm going to have to move it over a little bit to make it work. Does that make sense?
Yeah.
Since we don't have a right triangle, we're going to have to use law of sines in this case. But for the range equation, since what Jacobs and Shai were saying, since the displacement is horizontal, this shape does make a right triangle. Is this helping?
Yeah.
The questions you ask are important for everybody to deal with, so it's perfect. I would encourage anyone, if you have any questions, to ask now or any time. Cool. Whoops, I went too far. Okay, so we're all good here. I mean, it's pretty much done, dude. You solve for delta x. Isn't that your range? That's how far the projectile goes. And it's super nice to know how far a projectile is going to go for any angle and for any initial velocity. Those are the two things that are going to affect how far it goes. You guys good? So let's see what we got here. V naught t cosine theta. Is that right?
Yeah.
Everybody's good here? And I'm just talking magnitudes. I don't have vectors over these because my vectors are already drawn. So I don't have arrows over all my symbols anymore. These are just magnitudes now. It's much simpler. Cool? What am I going to do? And pretty much done with a task that used to drive people crazy. Like in honors physics, it was really hard. One of the hardest derivations we did. And it's pretty easy at this point. It should be like, okay. Yeah, you're not, how far a projectile goes is only going to depend on your initial velocity and your theta. And I'll finish this for you. All I would ask is that it's in your notebook beautifully. We will use it. I'll have an assignment with the rockets that we can use in real life. Cool? So delta x equals, help me with the derivation. V naught, what do I plug in? Okay, and tell me if you see the eye catcher.
There's two V naughts.
I don't know, no, I'm not hearing it yet. Take your time and think, please. This, yeah, I missed something? Okay, there's a V naught here, and there's a V, okay. All right, I'll do that. It's still not what I was looking for, but that's okay. It's a step closer. Now, does anyone see the eye catcher?
No.
Yeah, I do.
Okay, let me see if you see it now. If I take this, and this.
Wait a minute.
Oh, that's a trigonometric identity.
Beautiful. Which one is this?
I forgot.
So trig identity.
Cosine squares.
Now
Wait, if you divide both sides by cosine.
hold on.
It's sine 2a.
This is correct. Okay, there's nothing wrong with this. We just make it slightly prettier.
No, sine 2a.
Okay?
Wait, I got it. If you divide both sides by cosine, can it be delta x over cosine theta?
Okay, I heard it, Kevin. It's doubling. It's sine 2 theta.
See?
Okay? So now,
No.
is that cool? I mean, watch. Look how beautiful it becomes. It's like amazing. So I'm going to get rid of that, and just call it V naught squared sine 2 theta all over A. And we're done. Are you guys good? So now guys get on one side, girls get on the other side. Whatever. Guys go on
This side.